Welcome students. Today we will take chapter 2 polynomials identities. Now let us talk of identity 6. Here we are going to take x plus y whole cubed is equal to x cubed plus y cubed plus 3xy x plus y. Now this is one way of expressing this identity, and we are also having the other way to express this identity. Here the first two terms x cubed and y cubed are as they are. We are just going to distribute this 3xy over x plus y. That's all we are going to do. We will distribute 3xy over x plus y means first we will multiply this x with 3xy. Then what shall we get? We'll get 3 x into x is x squared and then y. The product of 3x squared y plus when we multiply 3xy with y, we will get 3 into x into y is y squared. So that's what we have done. So just distributed this 3xy. And we got the second way of expressing the identity 6. Now this expression is going to be used in our sum, which is over here. And using this expression, we will factorize and we'll get this factor form, x plus y whole cube form. So the first step is that we have to take cube roots of first two terms. What is the cube root of 8a cube? So let us take the prime factorization of 8. It will be 2 into 2 into 2. And the cube root of 8 will be 2. And the cube root of a cubed is 8. What will be the cube root of b cube? It will be b. Now replace this 2a with in the place of x, you have to write 2a and you have to replace y with b. That's all you have to do. First, you have to write this general form, and after writing this general form only you can replace. So don't forget to write the general form. We can write this general form, and then wherever you are finding x, you have to replace it with 2a, and wherever you are finding y, you have to replace it with b. But don't forget that you have to use the bracket. Now, on replacing x with 2a, we get 2a whole cube. Whole cube means bracket. Then replacing y with b, we get b cube. b whole cube. This b whole cube can be written behind also as it is over here, or it can be written in the front. It doesn't make any difference. Commutative property, you can write it anywhere. Now, the important parts are these two terms. Be careful while replacing the values. Here it is 3, then x squared means 2a. X is 2a. So you will take 2a two times, and y is b. Don't forget the brackets. And then last term is plus 3, replace x with 2a and y with b, but this time y is 2 times, so 2 times b. Now what is common in these two terms? 1 3 is common, then 2a is common, and 1b is common. Now what is remaining in the bracket? From here you are getting 1 2a, which is uncommon, and from here you are getting 1b, which is uncommon. And here we arrived at the factor form. This is the expanded form for the identity x plus y whole cube. So in the place of x and y, what have we replaced? We should replace 2a and b. So write 2a plus b whole cube. This is factor form. It is in bracket. Hence it is a factor form, and this is the expanded form. Now let us talk about identity 7. It is just as identity 6. The only difference is here in the bracket it will be subtraction minus sign in the place of plus. So wherever there was plus over there, here there is a negative sign. So you will get x minus y whole cubed is equal to x cubed minus y cubed minus 3xy and bracket x minus y. Did you notice over here that all the terms are in negative terms? So it's very simple. All the terms are negative. And this x minus y whole cube can also be expressed in the second form as over here. Here we have done nothing, but we have just distributed minus 3xy over x and y. How? You see, minus 3xy into x is minus 3x squared y. And minus 3xy into minus y is minus into minus will be plus. And therefore, you can see there is one positive symbol. All are not negative just because of this distribution. So alternatively they are positive, negative, positive, negative. Remember like that. Positive, negative, positive, negative. Because of this distribution, this term has become positive. So minus into minus plus 3x one time and y is 2 times and y squared. Even you can get this identity from identity 6 by replacing y with minus y. Wherever there was y in identity 6, you can use minus y. You will again arrive at the same result. At present, we are taking particular sum using the second expression, the second expanded form. So how are we going to use this expanded form is, let us first find the cube root of first two terms. They are over here. Cube root of 27 is 3 because the prime factorization of 27 is 3 into 3 into 3. Hence its cube root is 3 and p cubed will be, cube root of p cubed will be p. Similarly, the cube root of 1 upon 216 is 1 upon 6. Why? Because the prime factorization of 216 is 6 into 6 into 6. Hence, the cube root is 6. Now, we have to do nothing, just replace x of the general identity, this general form of identity. There will be x and y. Replace this x with 3p and replace y with 1 upon 6. So wherever you find x, you have to write 3p. See over here 3p, but in the bracket. So it is called 3p whole squared minus, this term is over here in the second place. So minus 1 upon 6 whole cubed minus, just replace x and y. 3 into x will be replaced by 3p, but 3p is 2 times. So here we have taken it 2 times. Then 1 upon 6 is replaced by, y is replaced by 1 upon 6, then plus in the last term 3 into x. What is x? It will be replaced with 3p. And what about y? It will be replaced with 1 upon 6 2 times. Now what is common among this? You can see 3p once, you can see the number 3 also once, and you can even see 1 upon 6 one time. So this is common. And what is uncommon? 1 3p from here is uncommon and 1 minus 1 upon 6 is uncommon. So we arrived at the form, which form? X cube minus y cube minus 3xy, x minus y. See, this form resembles this form. Therefore, what is its factor form? The factor form is x minus y whole cube. And instead of x, we are going to write 3p minus 1 upon 6 whole cube. The most important part is that you have to cube root it, and whatever you get over here, here you are getting 1 3p and 1 upon 6. Those two terms should be perfect. 3p minus 1 upon 6 whole cube. This is the requirement. This should be perfect. You can skip this part if you want to skip. You can directly write this. But we can explain both this part, then it is good. If you can explain both these steps, then it is good. But if you want to skip, you can skip this statement. You can directly write this statement and then this step. The last step is very important. The last step has no resemblance with this two, but it is very much necessary that you find the cube root properly. Once you get the cube root properly, this step is going to be correct. And this step is going to fetch you marks. Here we are arriving at one new identity using the previous identity 6. So we are going to derive another identity from the same identity 6. So how does it work? Like x cube plus y cube is equal to x plus y bracket of x squared minus xy plus y squared. Here all the terms are positive except the middle term. So remember that much, that here the middle term will have the opposite side of the sign which is in all the other terms. This way it will be easy for you to remember. Now, how did we derive this? So we already know that identity 6 is x plus y whole cubed is equal to x cubed plus y cubed plus 3xy x plus y. In this positive identity, all the terms are positive, so it is very simple. Nothing is negative, but here there is the middle term is negative. So from this we are going to derive. Here can you see x cube plus y cube? Shift it to LHS and then transpose this last term over that. Then what will it become? It will become minus 3xy x plus y. So here this is x plus y whole cube minus 3xy x plus y. Now you take out common, x plus y is common in both these terms. Can you see here x plus y? And here of course there is one x plus y because it is cubed. So definitely one x plus y is common. What is remaining in this term? 2x plus y means x squared of x plus y are remaining. Why? Here the power is 2, here the power is 1, 2 plus 1 is 3. So 1 power we have taken outside, the 2 powers, the power 2 are remaining. Of what? Of x plus y whole square. And what about the last term? Here we already took x plus y common, so we are only remaining with minus 3xy. That's all. 50% of your work is done. Now simply you have to simplify things. Here x plus y is as it is. In the next step, most of the terms are repeated. Here, now we have to expand x plus y whole square using identity 1. So what will it be? It will be x squared plus 2xy plus y squared. Just write in expanded form. After writing in expanded, this is factor form and we are writing it in expanded form. After writing in expanded form, simplify. Plus 2xy minus 3xy is minus xy. That is why this middle term is minus. See, from here you can realize why it is in subtraction. The middle term is in subtraction because of this two calculations. Plus 2xy and minus 3xy are like terms. When you add them, you get minus xy. So this identity we derived from our common identity 6. This is identity for x cube minus y cube. X cube minus y cube is equal to x minus y, x squared plus xy plus y squared. Here the middle term is in positive. The middle term is positive in and the first factor x minus y is negative. So when x cube minus y cubed is asked, here the first factor will be negative, but here the middle term will be positive. Now let us understand how we arrived at the result. We already know the identity 6, which is x minus y whole cube, that is x cube minus y cubed minus 3xy x minus y. Identity 7, right? This is identity 7. So now we want, from here we can fetch x cube minus y cube. So let us write it in LHS. And what about others? Transpose all this to the LHS. So what will happen? This will get positive. X minus y whole cubed is as it is, but when these are transposed, they become plus 3xy x minus y. Write these terms in right hand side because we have already written x cubed minus y cubed in left hand side because we want to verify it from LHS. This is the LHS. So after transposing these terms over here, write this entire part in RHS. Now here what is common? X minus y is common in both these terms. So write it outside the bracket. What is uncommon over here? X minus y whole square. And from here what you get? Plus 3xy. This is distributive property. But you already know from identity 2 that x minus y whole squared is equal to x squared minus 2xy plus y squared. Right? So we have just expanded this identity and then we have to write plus 3xy. So plus 3xy which is over here. Just we have written below again. We have repeated it. Now simplify. X minus y will be as it is, but here you can simplify minus 2xy plus 3xy is plus xy, which is the middle term. and I already told you that it is positive. Why it is positive? Because of this. Here it is minus 2xy, but here it is plus 3xy. So you get the middle term positive. And the first term is, the first factor is negative. X minus y is negative. This you can remember because in the question also it is negative. So it is easier for you to remember this and these are same. But here it is a little bit confusing, or you should remember that this is middle term is positive. Thank you.